Welcome to the second video of Module 6. So in the previous video, we were discussing about software quality assurance, its tasks, goals, metrics, attributes and so on. Now here, we are discussing about the statistical SQA. So just before the heading was formal approaches to SQA. So from then we come to the statistical SQA, SSQA, or what are the steps involved. So under this heading we will be discussing a general statistical way and also the Six Sigma method, okay, for statistical SQA. So the steps involved in SSQA are: the information about the software defects is collected first and categorized as low, medium and complex, or serious, moderate and low. Then, so whatever information about the defects, you have to categorize it, okay, from biggest to smallest to biggest, whichever. An attempt is made to trace each error to its underlying cause, whether one error is caused because of its non-conformance to specification, or is it a design error. So it is tried to trace back to its cause. Then third is using the Pareto Principle, that is, the principle says 80% of the defects can be traced to 20% of the causes. So 80% of the defects you can see are because of 20% of the causes. Okay, so if we find out those 20% causes, we have to isolate those 20% causes, which are called the vital few defect causes. So our major problem will be solved if we identify that 20% cases or causes. Then once the vital few, that is the 20% causes, have been identified, move to correct the problems that cause the defects. So this is the working principle of the statistical SQA. Now a general example. So let us assume the information about the defects is collected for 1 year and categorized as, now for example, incomplete or erroneous specifications, in short IES, then misinterpretation of customer communication, MCC, intentional deviation from specification, IDS, violation of programming standards, VPS, error in data representation, EDR, etc. So we have the defects, okay, and the short forms here. So the data has been categorized like this, that is, each of these error categories we have found out the defects in the serious level, moderate level, minor level, and found its total. Okay, so for IES, what is IES? IES was incomplete or erroneous specification. So because of that, the serious errors were 34, moderate 68, 103 minor errors, and then coming to a total of 205. Like that the others. Okay, so column wise totals are as shown. So we can see easily the following, that is, the IES, MCC and EDR are vital errors, which causes 53% of all the errors. So we check the total. Now if we say IES, it is 205, MCC 156, and EDL, is it EDL? EDR. EDR, it is 130. So these are the big values among the total. Okay, so they can be the vital errors, that is, according to the Pareto Principle, the 20% which causes 80% of the errors. So according to Pareto Principle, when we sort out, the major errors are due to these three, and if you count, they cause 53% of all the errors. Okay, though it is not 80, they are the master errors there, okay, or the vital errors. Then IES, EDR, PLT, EDL are vital only if serious errors are considered. Now we can even in a particular serious level, okay, if you consider which are the big values, okay, IES is 34, EDR is 26, okay, then you have values like 15 PLT, okay, then 14 EDL. So you can easily find out which are the vital. If serious errors are considered or if moderate errors are considered, you can find the vital ones, okay, like that. So we now start corrective action focused on the vital few. Example, for EDR, EDR stands for error in data representation. So what would be the preventive measure? Naturally it would be to review the data representation techniques to identify possible improvement areas and adopt some case tool for data modeling, then performing string and data reviews. Okay, so these are the possible solutions if you find that EDR is a vital cause, okay, or vital one among the vital few, that is problem in the data representation technique. Then you will have to go for correcting the data representation techniques as mentioned earlier. Next is the second method for statistical SQA, that is Six Sigma. It is important for your KTU. What are the core steps? It's quite simple. Six Sigma is most widely used for statistical quality assurance in industries. Okay, then it was popularized by Motorola in 1980s, and it is a rigorous and disciplined methodology using data and statistical analysis to improve a company's operational performance, identifying its defects. Okay, now to achieve Six Sigma, a process must not produce more than 3.4 defects per million occurrences. Okay, and this methodology defines three core steps. Okay, that is define, measure, analyze. One is define customer requirements. Then second, measure the existing processes outputs to determine the current quality performance. That is collect defect metrics. Okay, we had learned in the third module about metrics. Okay, so that will help us. Metrics will always help us to measure. Okay, then analyze defect metrics and determine the vital few causes. Okay, so these are the core steps. And if the existing software processes is in place, is means okay, working order, and if it needs an improvement only, then additional two steps are there. That is, improve the process by eliminating the root cause of the defects, then control the process to ensure future work does not reintroduce further defects. Okay, so that is applied if it is an existing process and it only needs an improvement. Okay, so these core plus the additional steps can be referred to as DMAIC. D for define, measure, A for analyze, I for improve, C for control, and this is for the existing process. And if it is for new processes, then it is DMA, the core ones, plus DV. Okay, where D stands for designing the process to avoid root causes of defects to meet the customer needs, then to verify the process model which will affect the defects and meet the customer needs. Okay, next main heading is software reliability. So it is defined as the probability of failure free operation of computer program, okay, in a specified environment for a specified time. So our product should be working without any failure in a specified environment for a specific time. Okay, next the measures of reliability and availability. Now for measuring reliability, mainly it is mean time between failures, that is MTBF, which is MTTF plus MTTR. MTTF is the mean time to failure, MTTR is the mean time to repair. Okay, another measure of reliability is failure in time. Just know these points. Okay, and next you have software availability, which is given by MTTF by the sum of MTTF and MTTR into 100%. Next, software safety. Earlier we discussed reliability, now safety. So we discussed the measuring reliability and safety earlier. Next is safety. Then software safety is the software quality assurance activity which focuses on identification and assessment of the hazards, okay, just like identifying the risks, okay, that may affect the software negatively and cause the software system to fail. So it is about identifying the hazards and assessing the hazards, okay. So early identification of the hazards will allow the developers to specify design features which can eliminate or at least control the impact of the hazards. Okay, for that some modeling analysis and all is conducted. Now initially, as we said, hazards are identified and categorized by criticality and risk. So this we have briefly discussed in risk management. Not briefly, actually in detail we had learned about it in the risk management, and this is briefed here. So once the system level hazards are identified, analysis techniques will ascertain the severity or the probability of their occurrence, and now safety related requirements can be specified for the software. Okay, once you find out their severity and all, we can spell out the safety related requirements for that particular hazard. So in short, software reliability involves determining the likelihood that a failure will occur, while software safety examines the ways in which the failure may result in conditions that can lead to the accident. Then next topic is the ISO 9000 quality standards. It's a KTU question. So what are the standards under ISO 9000? So ISO 9000 is actually to describe the quality assurance. It's for quality. To when you say your product is ISO 9000 certified, that means your product or the processes that are involved in making your product are of good quality, high standards. They should conform to the standards which are specified in ISO 9000 organization. Okay. So ISO 9000 describes quality assurance elements that must be present for quality assurance system to be compliant with the standard. But it does not describe how an organization should implement these elements. Okay, how is not a problem, but it does not describe how, but it should be compliant with the standard. Okay, now to become registered with one of the quality assurance system models which are contained in ISO 9000, a company's quality system and operations are scrutinized by the third party auditors. Okay, that is from the company ISO. That is whether the products are compliant to the standards and the operations are compliant to the standards. So for one particular standard, they do not need to cater to how it is being achieved, but the process should be of the standard. That is it. Upon successful registration, a company is issued a certificate. Now ISO 9001-2000 for software is the generic standard that applies to any organization that wants to improve overall quality of the products, systems and services that it provides. Okay, then the requirements explained by it are topics like management, responsibility, quality system and so on. Just go through it. Okay, then ISO 9001, next one, describes a QMS can be describes how a QMS can be applied to the creation of products and provision of services.